My name is Tom Sukanik. I'm the new chair of the Forum Committee. And I'd like to welcome you all to our new virtual fall forum series. We have a great lineup of speakers about every Friday from now until early December. I'm thrilled that you're joining us today because we have a special speaker to kick off our series. Everyone loves penguins, and we have a real treat for you today as we've invited a penguin researcher to tell us all about his research that he's been doing on penguins in Antarctica. However, we'll also have a special guest announcer as well, a world-renowned naturalist and broadcaster, Sir David Fattenborough, who will introduce our speaker, Dr. Grant Ballard. So, without further ado, let's go to Antarctica.
Hi there. Here we are on the edge of the Ross Sea in Antarctica, very near the South Pole. I don't see any snow or ice around here, and maybe that's because much of it is either melted or drifted away, as climate change has been impacting this area of Antarctica for decades. I wonder if there's any wildlife on this beach. Let's check. Oh wait, what do I see coming around the corner? Oh my, that looks like a penguin. No, it's two penguins. No, it's three penguins. My, they certainly are prolific little creatures down here. What a cute family. Let's go over to them. Hello there. Do you speak English? Try again. Well, that's not going to work. Here, try talking into this translator box.
Well, what does this box do?
Perfect English. So, first of all, why are you wearing a mask?
Haven't you heard of the COVID pandemic? We all need to be careful here, and we are social distancing and making sure we don't get infected.
Okay, I get it, but what are you doing wandering around this beach anyway?
Well, we've heard that there's a very famous penguin research biologist here named Dr. Grant Ballard, and he's been spotted in these parts, but have you seen him?
No, not yet.
Well, keep your eyes open because I think he's going to show up here real soon. In the meantime, do you know that Dr. Ballard has been conducting field research in Alaska and California since 1991? And in Antarctica, he's been studying the emperor penguins like we are, and also ADÉLIE penguins. And they're our little cousins, but they're really cute. So I've heard that he has earned his PhD from the University of Auckland in New Zealand. And now he's the Chief Science Officer at Point Blue Conservation Science Organization in Petaluma, California. And he manages over 160 scientists at Point Blue. He's also a fascinating speaker. And if we can find him, I'll bet he'd be more than happy to share all of his experiences in Antarctica and the Ross Sea with us. In these days of COVID, though, we can't be too careful. We wouldn't want him to get us infected or us to get him infected, so we need to maintain distance. So let's see if we can find him on the internet instead. I see a computer over here on the beach. Well, let's see if I can get on the internet and find him. Okay, here goes. Be quiet in the background. Oh, there. I found him. And I think he's going to speak for us. Here you are, Dr. Grant Ballard. Thank you.
Well, hello, everyone. It's really great to be here. And I'm sorry I can't be with you all in person today. but I think we're all getting used to the Zoom format, so we'll see how that goes. I just want to do a quick check that you can hear me, and if someone could indicate that either on the question and answer box would be useful for me to see that. Because I can't see anyone right now. I'm just looking at my screen.
You're doing fine, Grant.
Great, thank you very much. All right, so I'll do a, thank you everyone, good. I'm gonna do a talk that'll be about 40 minutes long, and hopefully we'll have plenty of time for question and answer. And we're talking about, mostly about Adelie penguins, which are these penguins that you see on the screen right now. And a mystery that we've been trying to solve, which is why are some penguin populations in the Ross Sea area growing very rapidly during this time? So just a little bit about Point Blue, and thank you for that zany introduction, Tom, and co-penguins. I've never had an intro like that before, and it was really something. Thank you. I need one of those translator boxes. So Point Blue is a conservation science nonprofit organization that was founded in 1965 as Point Reyes Bird Observatory. And there are about 160 scientists involved with the organization, and we are basically working to advance the conservation of birds, other wildlife, and ecosystems through science, partnerships, and outreach. And science is at the core of everything we do, but we can't do the work we do without the partnerships and the outreach piece too. And partnerships in particular are with natural resource managers. So we work hand in hand to basically help improve conservation outcomes. And natural resource managers can be anybody from private landowners to government agencies to industry or whoever has resources that they need managed. And our vision is that because of the work we're doing today, there will still be healthy ecosystems sustaining thriving wildlife and human communities on land and at sea for decades to come. So hopefully that's a vision that we can all get behind. And over the past 20 years, we've done a lot of work. I'm going to be talking almost exclusively about our work in oceans and in the Southern Ocean in particular, around Antarctica. But we work on all kinds of different things, including on private lands and agriculture in California. And that work has resulted in an additional 100 million that wouldn't have been invested to improve conservation outcomes across 2 million acres of privately owned land, mostly with small family farmers and ranchers. We've worked to establish the largest marine protected area in the world, which I'll talk about today. We've trained a lot of people in the techniques for doing field biology, and they come from all around the world, and they mostly go on to have careers that continue that impact. We work from Alaska to Chile with volunteers, keeping track of all the shorebirds in the estuaries up and down the coast. And we also work in the Sierra, and we've helped to make more than 500,000 acres of post-fire habitat worth more to the animals that use that kind of habitat. So as you all know, the Earth is getting warmer, and this animation is by a guy named Ed Hawkins. And let's see if I can get it going. There it goes. And it basically is showing these lines around, basically as for every year we add another line. And as you can see, in recent years, it's really jumped quite a lot towards that 1.5 degrees Celsius that we know is probably about the limit of what's really safe for us and for ecosystems on the planet. And we really don't want to get to the 2 degrees C line. 1.5 degrees C is what the participants in the Paris Accord sort of identified as really the better target than 2. We hear 2 a lot because that might be more realistic. Unfortunately, we probably have already set the, we've already opened the door to the 2 degrees C mark, and we'll probably be getting there, but hopefully we can reverse that. So I'm going to talk today about some specifics around sort of the way these kinds of climate change effects or the warming is affecting things. And I think one that's obviously really close to home is the fire season in California. This graph is showing the duration of the fire season starting back in 1970 and up through 2012. And the width of the area that you see in red and black is the overall duration of the fire season. And the takeaway message is that it's increased by 84 days over this period of time. This is the period of time that severe fires are occurring in the Western United States. It's an 84-day longer period than it used to be. So the earliest fires are on average earlier, and the latest fires are on average ending later in the year. So switching to Antarctica and why go to Antarctica, why study Antarctica. It really is considered a natural laboratory, and that's true for a lot of reasons. And one of the reasons is that it's a place where you can go and drill a hole in the ice and go down about 3 miles and retrieve an ice core that has air bubbles in it that are 800,000 years old. And in fact, some of the oldest ones now, the newest ice cores that they've developed new techniques of extracting even farther down than that, have air bubbles that are from 2.4 million years ago. So from doing that, we can actually sample across those ice cores and look at how much carbon dioxide there was in the air, in the atmosphere on Earth, going back 800,000 years in this case. And you can see that it cycles up and down naturally. And then the very far right is today, the present. And with that cycling, the temperature in Antarctica has also been basically closely tracking. And of course, that's true of global temperature as well. So the blue star is where our carbon dioxide levels are today at about 410 parts per million in the atmosphere. As you can tell from this map, this graph, that hasn't happened in the last 800,000 years. In fact, not even close. You'd have to go back probably something like 4 million years to see carbon dioxide at that level. And of course, humans have only existed in sort of the modern format that we're familiar with. And really over this period that's in the circle here, this is the Holocene era, which is kind of our sweet spot. It was a very stable period of temperature and carbon dioxide. And so what's alarming to climate scientists and to lots of other people is that we're way outside of that circle now. So all our species is really known as this sort of really kind of small range. And if you look back through the 800,000 year history, you can see that it's sort of a rare and special time. There were other periods that approximated it, but not that many in 800,000 years. So I think just calling attention to how special this time has been, that we have developed civilization over the past 10 to 12,000 years, is an important realization for people to have. So how does this affect things? How does this warming affect things? Well, we're going to talk about different kinds of ice and the effects of change on that ice. And the main one that is of the biggest concern that you see the most headlines about is the loss of glaciers and the loss of the ice sheets. So in Greenland and Antarctica, where the biggest ice sheets exist on Earth, there is definitely change. And this is showing in green the change in the Greenland ice sheet, and in blue the change in the Antarctic ice sheet. And basically the Greenland ice sheet has changed more than Antarctica so far, up till through 2018, this graph goes. And what you're seeing on the vertical axis here is the number of gigatons, or millions of tons, billions of tons of ice that have been lost during this period of time. So in Greenland, it's been something like a 4,000 gigaton change, which is the equivalent of about 11 millimeters of sea level rise. On the right vertical axis is sea level rise. So changes in these glaciers have impact to sea level. So far, not very much impact. The change in Antarctica has been less. Antarctica is more protected from climate change than the Northern Hemisphere. It's basically a big, solid chunk of ice right now, and we hope it stays that way. But it is losing mass. And you can see that starting at about 2004, that started accelerating. And so that's of some concern. And just because this isn't actually going to happen, so don't worry, or at least not in any of our lifetimes, if the entire Greenland ice sheet melted, that would be about 20 feet of sea level rise. The big problem with that is that if that happened, then also all the rest of the ice would be melting too. So if all the ice on Earth melts, we would have 230 feet of sea level rise. That is not going to happen anytime soon, but I just wanted to throw that in there so you have an extra factoid to take away. So I'm going to talk a little bit about the different kinds of ice, and this is a picture taken out of the window of the airplane that takes us to Antarctica every year. And in this picture, you can see different kinds of ice, and it matters what kinds of ice it is. So in the foreground is sea ice, which is frozen ocean, and there's some of it that's in these sort of chunks of larger flows, and then these are smaller flows to the left. And to the right, we have what's called fast ice, which is also frozen ocean, but it's locked in to this glacier. So all of this ice here in the foreground is salt water, frozen salt water, and there's some open water in between. And this stuff is the habitat that penguins, or at least Adelie penguins and emperor penguins, really need for their existence. They're specially adapted to that habitat. Up here you have a glacier tongue that's sticking into the ocean, and that is freshwater. So, and that the wall there would be about 50 to 100 feet high. So there's a bunch of fresh water sitting there, and it connects up into the mainland of Antarctica, and that's what you see in the back. Most of Antarctica looks something like this. It's mostly covered in ice. In this picture, there's a little bit of a different phenomenon going on. This is what's called a polynya, P-O-L-Y-N-Y-A, and it's caused by wind, and there's a lot of wind in Antarctica, and it basically blows the ice away from shore and leaves open water, which is really important so that penguins can get into the water and find their food. So that's an important feature that exists around the coast of Antarctica. So I'm going to show a little video clip that shows some of those features. This is taken from a drone, and this is taken at Cape Crozier where I work. I've been working since 1996. And we've been studying the Adelie penguins. And if you have really good eyes, and if your monitor is big enough, you might see there's some penguins down here. We're going to get closer to them in later slides, but there's a bunch of penguins on their nests down in here and the brown stuff. And also there's penguins, thousands of penguins lined up against this crack in the ice. This is all fast ice out in front here. And then in the background is the edge of the Ross Ice Shelf, which is the largest glacier in the world. And off to the left is the open ocean. You can actually see an ocean swell. So I'm going to play the video. And this was a really lucky day to be taking videos, because it was the day that the fast ice was breaking up. And it breaks up in these spectacular patterns that are just fascinating. We don't often get to see it from above because we don't fly around all that much, but we had UAVs with us this year, so we can take these footage. This footage was taken last December. You can see the swell. The swell probably is what's breaking up the ice, and it shatters into millions and millions of these geometric shapes. And there's penguins all over the place. This line of penguins, like thousands of penguins, going out to the ocean, and they're excited when this breaks out because it gives them a much shorter walk. My doorbell is ringing, apparently. It's really loud, sorry about that. And they're trying to get into the water so that they can get to their fish and krill. So sea ice in the world is also declining, much like the glaciers are, especially in the Arctic. So over the past 40 or 50 years, since we've been tracking it with satellites, it's declined really rapidly in the Arctic. Not as much in the Antarctic. In fact, there was an overall trend of increasing Antarctic sea ice, all combined, until probably around 2016. And then 2017, there was a really bad year in 2017, and the last few years have all been low in Antarctica. So we might have crossed a threshold there, or it might just be a blip. It does happen. So we're keeping a close eye on that. Overall, when you combine the Arctic and the Antarctic sea ice, there is a negative trend in sea ice globally. But just like the fire season that I was talking about in the West, that has changed by 84 days. So we have 84 days more of extreme fire season, the ice season, the period of time that the ice grows in the Arctic and the Antarctic, has also been changing. And these changes are really important to kind of wrap your head around. This is like, if you think about how long summer lasts, or how long winter lasts, or how long spring or fall lasts, those are important things for us. We know those seasons wherever we live, and we keep track of them. So for the Arctic and Antarctic ecosystems, this is really a key number. And the fact that the ice season is 90 days shorter than it used to be just 40 or 50 years ago is kind of mind-blowing. That's a 3-month change in the period of time that the ice sheet, the sea ice, is growing. And there's a similar trend for the Antarctic Peninsula area, which is the area south of South America. In the Ross Sea region where I work, it's actually gotten longer. There's an 80-day longer sea ice season. So that might be part of the mystery that we are going to be talking about, so file that away. But a lot of people ask, well, why is that? Why might that be? And we don't actually know, but climate models are getting better, and they're starting to say things like, well, maybe it's because there's actually more fresh water in the Ross Sea now than there used to be. It's still cold enough, but it's getting fresher. It's getting warmer, but it's not so warm that it doesn't freeze. And fresh water freezes more easily than salt water. There's also more wind than there used to be. And this is data that we've collected at our field station in Antarctica on Ross Island. And it definitely, the number of windy days has gotten higher over the past 24 years. And that actually helps generate more sea ice in that area. So when we started this study back in 1996, and it was actually picking up a study that had been started in the early 60s by researchers from Johns Hopkins University. We're basically kind of just pure ecologists, sort of asking these really fundamental questions. Why do animals live where they live? You know, Adelie penguins and emperor penguins are uniquely adapted to live in the coldest environments on Earth. But why do they live in the specific places they live? And things like that are hard to study in most places on Earth because human activities have altered most of the Earth's ecosystems pretty significantly. So the answer is almost always because humans did something. So we're trying to get at the question from a more fundamental perspective. Like, okay, so what if humans weren't involved? What if humans weren't interfering with the environment so much? So in that sense, we're hearkening back to Aldo Leopold, and as he was very articulately stating in the Sand County Almanac from 1949, this idea of a base datum for normality, where you still have an intact food web. All the pieces are still there. You haven't lost any of the pieces yet. And it also addresses sort of a fundamental challenge in conservation biology, is that we get used to what we experience. So there's a shifting baseline. And then that allows for ecosystem degradation sort of slowly in front of us, sort of like the apocryphal story of the frog in the boiling water that, you know, gradually heats up until it's dead. We need to be able to break this cycle. We need to be able to use long-term data and trust that long-term data to know that things are actually changing. And that goes back to that 800,000 year history of the atmospheric carbon dioxide that I showed you earlier. That's the kind of thing that we need to really pay attention to. So the study area that I work on is in the red box, and we're way over here on the other side of the world. And basically, this is called the Ross Sea region. It's south of New Zealand, and Australia is over here. And this is what it looks like from a satellite, those satellites that are tracking how much ice there is. This white area, most of the white on the edges is glacier. The white one at the bottom is the Ross Ice Shelf, the largest glacier in the world, part of the West Antarctic ice sheet. And this is a very large polynya, the Ross Sea polynya. So again, that's caused by wind, and there's really strong winds here, and it basically keeps all the ice offshore. But that water is constantly freezing. It's below zero, a little bit below zero, and it freezes very fast. And then the wind blows the ice away, and it refreezes, and that's what's sort of like an ice conveyor belt, if you will. And around the edges of that are this area called the marginal ice zone, and that's all sea ice. And that's where all the animals are. They love that habitat, and that's because stuff grows on that sea ice, diatoms, algae, and then krill and fish can graze on that, and then on up the food chain. This dashed line here is the basically where the deep water starts. So this is a pretty big continental shelf area of not so deep water. And in 2008, a guy named Ben Halpern published a paper that basically assessed how much impact humans have had to the global ocean. And basically the areas in darker orange, brighter colors are areas that have had the most impact. And you can not unexpectedly see areas that have been heavily mined for oil and heavily fished get the darkest colors. And if you notice, all around Antarctica, there's a lot of blue down there still. There's some blue left up here in the very far north as well. And those are places that are relatively untouched, and mostly because there's so much ice there that's actually very dangerous for humans to spend much time there, and ships, most ships can't handle it. The Ross Sea turned out to be the place with the lowest impact in his analysis anywhere in the world. Another interesting thing about the Ross Sea, and that's this area right here where the red arrow is pointing. And this is a satellite image that shows how much chlorophyll is being produced. So it's basically a measure of how much photosynthesis is happening, which is in turn really how many diatoms, how much algae is there, how much growth there is. And this is a really important thing to think about, because the ocean does act as a carbon sink in some places more than others. And this is one of the biggest carbon sinks in the world. It's about the equivalent of 10 million cars per year that are being taken off the road essentially by this ecosystem. And that is a significant amount. You can see most of the rest of the Southern Ocean doesn't come anywhere near that. But there's about 32 million cars in California. Hopefully this year we're driving less. If there's one silver lining, I think we're producing less CO2 with our cars anyway. But it is sobering to realize the magnitude of the problem that we're dealing with. So speaking of carbon dioxide, I am not a saint. I do fly to get to Antarctica, and my airplane looks like this. It's a US Air Force C-130, and it has special skis on the bottom. And that's the workhorse of the Antarctic program. And that's how we get down to Antarctica from Christchurch, New Zealand. So we fly to Christchurch, and then we fly to a place called McMurdo Station. And it's a long ride. It can take 9 or 10 hours, and then you might have to turn around and fly all the way back without stopping if the weather has gotten bad by the time you get there, which does happen. It happened to my entire team last year, unfortunately. They had an 18-hour day on an airplane. That, on the inside, looks like that. So it's not fun at all. The novelty wears off pretty quickly. You're basically interlocking knees with the person across from you, and you have to have whatever carry-on you have on your lap, essentially. Not the most fun, but it's all worth it, because when you get there, you land on this crazy sea ice runway. In this case, you can also end up landing on a glacier if the sea ice is broken up. In this case, this is a different airplane. It's a jet. Sometimes we get to fly on a jet instead, which is a little faster. And then you quickly have to go through a whole bunch of training, which we call Happy Camper School. And they make you stay out for 24 hours and prove that you're not going to die after they teach you how to do some things. This is building what's called a quinsy. And a quinsy basically involves taking all of your stuff and making a big pile of it and then stamping snow all over that. And then you dig out your stuff from the side, and there's basically a cave, and you can sleep in there. The thing behind this person is a Scott tent, which is a lot more comfortable to sleep in actually than the quinsy, but the quinsy is kind of fun to make. And you see all the flags. That's because we get whiteouts, and sometimes you need flags even closer than that to be able to see your trail. So then we get to go in the field, and this is the best part. I'm going to show you a quick video of what it looks like to arrive at Cape Crozier. So this is another UAV shot of our camp at Cape Crozier. That's our hut. It's about 16 feet long. There's a South Polar skua checking the drone out. And then we have these Scott tents. So we actually sleep in the Scott tents and we work and cook inside the hut. You can see we're all solar. We got solar panels, and we use propane for heat and for cooking. So inside the hut, it's like that. On a stormy day, we're all kind of cooped up in there. And there's usually 4 or 5 of us there. And you can see we sort of make the most of the space. It's pretty full of gear, lots of computers, lots of drying clothes, and that sort of thing. And all of our stuff has to be, we basically have there's a leave no trace policy. So all of our urine and solid waste is flown out on helicopters back to McMurdo and then shipped back to the United States for processing. So it's very expensive and kind of exciting. This is one of our team. This is Dr. Annie Schmidt hooking up a sling load of urine and gray water to be taken out. So we get trained on how to do all kinds of things like work underneath helicopters without killing ourselves. So here's what it looks like on a windy, kind of a bad day in Antarctica outside the hut. And hopefully the sound is going to be good for you. So this is about 85 miles per hour of wind at this point, and it's really taken apart this mountain tent. So we need to get Marina's sleeping kit out of there before it blows away. So you can see the back of the hut is all whitened from basically all the ice crystals being added into there over the years. It's a double-walled, metal-sided plywood. So tents, these kinds of tents don't hold up very well. Okay, so what are we doing there? Why are we having this adventure? Well, basically we're studying the ecosystem, and we're trying to understand, as I was saying, why some of the penguin populations are growing. And to do that, we look at all aspects of the ecosystem. So we are keeping track of how much krill the penguins are eating. This is their favorite krill species. There's a couple of different krill species, but mostly they're eating this one called crystal krill. They also like to eat this fish, which is called an Antarctic silverfish. It's like an anchovy. They get to be about 20 centimeters. The penguins are usually eating ones that are a little shorter than that, more like 10 centimeters long. And there's also Weddell seals there, which are kind of a competitor with the penguins. They also eat, they eat some silverfish, but they also eat this other thing called toothfish, which I'll show you in a minute. And they're amazing. They're like emperor penguins and polar bears in that they're totally reliant on fast ice to have their whole breeding cycle. And then emperor penguins, which you probably know about, but there's a lot of them in the area that we work, and they mostly eat silverfish. And then there's the Antarctic minke whale, which is an adorable, relatively small minke whale. All minke whales are small, but this is the smallest one on Earth at about 20 feet, 20 to 25 feet. And then there's this guy, the Ross Sea killer whale, which is the smallest killer whale on Earth. And they eat toothfish. They seem to be toothfish specialists. And this picture, this killer whale actually has a toothfish in its mouth. And there's a bunch of other killer whales underneath looking at it. And I think they're social in that way that they might share their food, which is kind of cool. And then there's the toothfish itself. And the toothfish is also called Chilean sea bass, and that's how it's sold here. So think twice, please, about ordering that or buying it. You'll learn a little bit more about it in a second. But basically, they're a very big fish, and they live a really long time, and they're very slow to reproduce. And they eat a lot of silverfish. These fish were actually returned. They're tagged and released fish. They're being studied by these guys. And then there's, of course, the Adélie penguins. And we have about 38% of the world population in the region that I'm working. And they eat, like I said, they eat a lot of krill and silverfish. So I'm going to give you a quick video that shows you some of their behaviors. This is what the colony looks like. They basically breed in these large aggregations. This colony is put here about 300,000 pairs of penguins. They set up their territories and they fight. Either be two males that are trying to establish who's got which territory. Then they mate up. This guy in front is advertising that he's available, looking for a mate. This is a female carrying a rock back to her nest. And her male has just relieved her. So they take turns and keep eating the eggs and also feeding the chicks. And nest maintenance is one of the most important activities because when the ice melts, which it does at some point during the year every summer, it starts flooding and the rocks help to keep their eggs and chicks out of the water. So this is what they look like when they're heading back out to sea. They get all dirty. I just left a camera set up on what we call the penguin superhighway, and they basically do this all day long, in and out, in and out. These penguins that are heading out are dirty. This is a tip for the one that was tobogganing. They slide on their bellies. Sometimes they come home and somebody else is on their nest and they bite them off. See in this picture, there's a lot of bigger chicks around. They also have to chase the skuas away. The skuas are predatory seabirds. The eggs hatch around December 15th every year. Chicks are born at about 100 grams each. There's 2 chicks. And they grow very quickly. Actually, these guys are about maybe 10 days old. And not long after that, they're left on their own to fend for themselves in a creche. This is called a creche. So there's some adults around still, but their parents are probably both out at sea catching food for them. You see, I'm kind of running a little low on time, so I'm going to skip ahead. This is called a feeding chase. That's what happens when they get to be basically teenagers. They're amazing in the water. That's called porpoising. And they jump out of the water really well. They're trying to avoid getting eaten by these leopard seals. Leopard seals can eat 10 per day each, and sometimes there's up to 10 leopard seals hanging out in front of Cape Crozier, but they need the conditions to be exactly right. Normally the penguins can get away from it, but sometimes when the ice conditions are bad, the penguins have a hard time. All right, so let's skip to here. Here's an emperor penguin that hopped out of the water and is trying to look cool. He looks very cool. All right. So Adelie penguins exist in colonies all around Antarctica, but most of the colonies are really small. Most of them are less than 1,000 pairs of penguins. There's only a few that are more than 100,000 pairs. So the question is, why are those so big? And in fact, those are actually growing. The biggest ones are actually growing. So this map shows Antarctica, and the Ross Sea is down here, and areas where there's a lot of blue is areas where there's more. That sea ice season that I talked about earlier is actually getting longer. And areas in orange and yellow are areas where that season is getting shorter. So the penguins that are red colored here indicate colonies that are declining or disappearing. And then the blue ones are areas where the penguin colonies are getting bigger. So at first, when we started studying this, we're like, this is a no-brainer. It's all about the ice. We're not sure exactly why, but they like ice. There's more ice. That's probably good. Maybe it has something to do with how much food they can get to or something like that. And we've been taking a ton of data. We do a lot of careful observations of all kinds of things, aspects of the penguins, and we write it down in these orange notebooks because we'd love to use tablets, but the tablets freeze and they're really hard to use with gloves and stuff. So we're still using notebooks, although we're experimenting with voice data entry on devices now. And over the years, the penguin colonies have indeed been growing. This is on the vertical axis is a log scale of how big the colony is, so it's not a normal scale. So in other words, the more you go up here, the more it's like an exponential increase. So the largest colony that we've studied at Cape Crozier has grown the most. And other colonies that we study, which are sort of medium sized, have grown as well, starting around 2000. But the smallest colony that we study at Cape Royds is only a few thousand pairs. It's actually been relatively stable maybe declining a little bit. At the same time, at Cape Crozier, that same colony is really big and has been growing. The number of chicks that are being produced has actually increased over time. It's sort of up and down, but the most recent years have been really good. So they're having a sort of a boom. Now, so maybe it has something to do with this fishery that started. So there was a toothfish fishery that started, and I actually saw the first fishing boat that came in 1997. And it really got kicked off in 2000. So that area is not actually pristine. In the region, there is a fishery, and it's mostly New Zealand, Korea, Japan, some UK. It's not a lot of fishing boats, but they are allowed, this is called a precautionary fishery. They are allowed to take up to 3,500 metric tons of toothfish per year. And that's the equivalent of about 35,000 fish, maybe even 40,000 fish per year. So if you think about it from like, if we thought about them as penguins and you said, oh, we're going to kill 35 or 40,000 penguins every year, you can imagine that that would put a dent in the population pretty quickly. The theory with fisheries is that they replace themselves over a certain amount of time, but we're not convinced because these toothfish seem to not reproduce all that quickly. And we also have the study that I told you about with the toothfish to look at, and they were actually able to catch very large toothfish in their study up until about the same time that fishery started, and their results started falling off really rapidly. So now we have this other potential mechanism for explaining why the penguin colonies might be growing. If you're taking away a competitor that also eats the same thing they eat, maybe that's good for the penguins, which is a little bit tricky from a conservation perspective. We've also seen that the number of killer whales that specialize in eating those toothfish are actually declining. So what can we do about that? What should we do about that? As you've seen, we've taken this ecosystem perspective and really trying to look at who's eating who and where they all live and how they use the ocean. And fortunately, we were able to collaborate with really an unbelievable number of scientists who all became concerned that there was a big change happening in this area at about the same time, about 42 different scientific teams. So this is just a sample of the different data that we were able to get. Lots of tracking data, lots of observations from ships, lots of satellite trackers, and put it all together in a compilation that basically ultimately resulted in us creating a conservation prioritization for the entire region. And we were very happy to be able to work with the organization that manages this area very closely. It's an organization called the Commission for the Conservation of Antarctic Marine Living Resources, or CAMLR, which is comprised of 24 countries. And basically, they have agreed to a consensus-based decision-making format. So they all have to agree on the establishment of anything like a marine protected area. And so the continent of Antarctica is actually protected from resource extraction, but the ocean is not. So we presented this conservation ranking, and we had all the data behind it. And we basically argued that you basically have to protect the entire region because the different species are using different parts of it in different ways. And so from that, we were able to help draw the boundaries of what did become the world's largest marine protected area. This is a graph that just shows sort of which countries agreed early on to this, to the marine protected area, and all the different countries that are involved. And you can see some of the holdouts: China, Russia, Japan. I think, China and Russia in particular didn't really have a lot at stake, actually, because they don't fish there. But geopolitically, it's important. There's a lot of reasons that they don't necessarily want to concede anything anywhere on the earth right now. So that's tricky stuff to negotiate. Unfortunately, I didn't have to do that negotiation myself, but they did ask. They went through the science very closely, and it was helpful that they were able to go to that science and we were able to hold it up as rigorous. So what's next? The rest of Antarctica needs protection also. There's a lot of proposals to create other marine protected areas, and I'm not as involved in those, but I'm sort of cheering from the sidelines and helping when I can. And the Weddell Sea is a big one that needs doing. There's other ones all around East Antarctica as well. So just a quick plug for Point Blue. You can check us out on the web, and that's probably the best thing to do at this point. Is if you're interested in what we're doing and want to help be part of the climate smart solution to improve conservation outcomes. There's lots of ways you can do that. You can obviously give us money. You can volunteer. You can just read our stuff. So consider doing that. And with that, I'm going to turn it over for questions. Thank you.
Hi, Grant. This is Christy. I'm helping out with questions today, but you must have covered everything everybody wanted to know, because we haven't got a single question from anybody. So you've got another 10 minutes to keep on talking. Unless something comes in the meantime, I'll let you know.
Okay. Well, I ran a little long, but we got a little bit of a late start too. So I'm happy to take any questions. And I could also go back to some stuff that I didn't cover. Potentially.
Why don't you go ahead and do that, and I'll just monitor the questions if something comes in the meantime. I'll let you know.
Okay, I'll do that. Let's see.
Somebody is asking, what's the website to get information again?
Pointblue.org. I'm seeing lots of questions now all of a sudden. So www.pointblue.org is the website.
Okay. Somebody else is asking, how has COVID-19 affected your research?
Oh, well, so this year we're going to be going to Antarctica with a very small team. We usually have about 10 people, and this year we're only going to have 3 because the U.S. Antarctic program is doing a lot of, they're basically trying everything they can to prevent COVID from getting to Antarctica. It still hasn't gotten there. So we're gonna have to do like a really rigorous quarantine, which I'm not looking forward to. I'll be spending 5 days in a hotel in San Francisco. Even though I live in San Francisco, I have to go to a hotel and promise that I'm locked up in there. And then I go to New Zealand, in Christchurch, and I stay locked up in a hotel there for 2 weeks. I'm not allowed to leave the hotel room for 2 weeks. And then, if everything's good, they're gonna test me a few times. And then get to go to McMurdo, and then I'm quarantined there for a week. So normally it's not quite that bad getting to my field site. So yeah, COVID's definitely affecting us this year. A lot of our field work across California got slowed down, but we were able to, in the end, do it following new protocols that we figured out with guidance from public health officials and that sort of thing. So for the most part, we're still doing all of our work. The most impacted has been the ship-based work. We're not able to be on ships right now because of COVID, which is understandable. So we've delayed or canceled all of our cruises this year.
Okay, great. Well, now we have 17 questions, so we got the rest of time. Here we go. So the next one is, how much time do you spend on the site every year?
I go, at this point, I'm going for a month every year, which is about the minimum I would go because it takes, it's pretty hard to get there. The normal, like sort of the full season is 3 months. So most of the team that goes spends 3 months there.
Great. Somebody else has asked, what temperature does salt water freeze, and how much colder is it than?
That's a great question. So it's about minus 2.9 degrees Celsius. And I'm not sure of the exact conversion, but it's somewhere, around the 28 degrees Fahrenheit or something like that.
Okay, so somebody is saying, I'm unsure from your talk if the objectors did finally agree to the protected area. They
did, yes. So I'm sorry I didn't make that clear. Yeah, it was a big win. I couldn't believe it. It didn't look like it was going to happen. And then eventually they did. So we had to make some concessions. So we allowed more fishing than I wanted to. And we also had to allow for a sunset clause on it to be reevaluated. So I wanted it to be forever, of course, but it ended up being a 35-year opportunity for revision. So in 35 years, it'll come up again for vote. And you see this area that's labeled SRZ, that's Special Research Zone. And essentially, there's still some fishing in that area, which is unfortunate because that's one of the most important areas for biodiversity. There's also fishing allowed in this area over what's called the Pinell Banks, which is also I initially wanted to, I had drawn a line like kind of like above that. So if you look in this map, it's hard to tell, but basically the area I'm talking about is this dark brown area. That area is not protected, and I wish it were.
Very good, thank you. And someone has asked, can you describe a bit more about the life cycle of those penguins? How did they spend their days and across the year?
Sure. So on a daily basis, there's different phases. So during the breeding season, they're basically either setting up their territories and flirting with other birds, or they are incubating their eggs, which is tedious. So when they are incubating, they just sit there for 2 weeks, more or less. Then the chicks hatch, and then they have a lot more excitement, and they're basically taking turns on basically every 2 or 3 days. They'll take a shift. Each parent will be going out to sea and swimming around, trying to catch as much food as it can, and then bringing it back to the chick. And then sort of at the end of the breeding season, when they're done feeding the chicks, they just have to start eating a lot so that they can basically store up enough energy to molt. And the molt happens in basically mid-March, and it takes them about 2 weeks to molt all of their feathers. And during that time, they have to basically sit on a piece of ice and not eat. And so then they get really hungry again, and they eat a lot. And then they spend the winter. They do a long migration all the way around this Ross Sea area, and they actually ride a current called the Ross Sea Gyre. And I can show you sort of, they basically leave Ross Island, they go over here and molt over here, and then throughout the entire winter, which is our summer, they basically make a big loop, and they're essentially riding an ice current, and then they come back at the end of the summer, end of the winter, to breed again.
Okay, so the next question is, what months are the researchers there?
We are there from basically November 1st to end of January. And we're going to start staying into about February 15th because we want to do some new work with the chicks. And so right when they're fledging, we're going to attach some satellite transmitters to chicks, which is the first time we've ever been able to do that.
Okay, I think we only have time for just a couple more questions. How about telling us something about your emotional connection with penguins? Do you like them in a special way?
I love penguins, and that's why I go back every year. It's really, they're amazing. And I have been working with some of the same penguins my entire career. So I don't think, I mean, I consider them my friends, but they certainly don't think of me that way, I'm sure. But they don't run away from me, so I take that as a compliment. So, yeah, no, I can sit and watch penguins all day long, every day, basically. To me, there's always something new to learn. I've gotten to the point where I think I understand a lot of their calls and their vocalizations and the context of what they're up to. So every time I go back, I'm learning more and more from them, and they're inspirational. They're hardworking, no nonsense mostly, but occasionally they do some silly stuff, and you're just sort of wondering, are you guys playing a joke on me right now, or what are you doing? So yeah, they're just constantly educational and entertaining.
Okay, and I think the last question is going to be, are leopard seals the only predators of penguins?
Leopard seals are the main predator in our area. And in some other areas of Antarctica, killer whales can also be a major predator. But we haven't seen killer whales impacting them. And in fact, the killer whales that live in the area that we work do not seem to have any interest whatsoever in anything other than toothfish.
Very good. I think we're turning this back over to our host then.
All right, thank you.
Thanks,
Thanks, everyone.
Thanks, Grant. That was fantastic. What a place to visit. I'm sure everyone would like to go down and get crammed into one of those C-130s.
Yep, C-130.
Okay. Okay. So, Grant, thank you so much. I'm sure everyone really enjoyed it, and we'll get you some kind of a reward here soon. Maybe we'll let you borrow the penguin costume. How's that? I guess you're on mute there. So anyway, fantastic presentation. Oh, there you are. Appreciate everything you've done, and I'm glad we finally got to do this. This has been a year in the making, not just the film, but the whole process after we got COVID. So I'm glad we were able to bring it to fruition. So I'm going to just put up a slide here and show you what's going to happen next week. So we'll be back again next week. Thanks, everybody. I think there was 174 people there at one point. Bye.